This is Algebra 2 with trig. We're working on unit 2B.7, rational zero theorem. What we're checking out here is, what if we don't know what a zero is, or what a factor is of our polynomial function? In a previous lesson, we were given what the factor was, and from the factor we were able to figure out the zero, and from the zero we were able to use synthetic to determine the quadratic, and with the quadratic we could figure out what the factors were. In a different set of questions, we were given the zero, and the zero can get us the quadratic, and the quadratic can get us the factors, and the factors can get us the other zeros. So that's really nice. But what if we don't have either one of those? What if we just have the polynomial? So if we don't know what the zeros are, we're going to use the rational zero theorem. Okay, this is going to say that the factors of the constant term divided by the factors, put an S with those factors because it is plural, factors of the leading coefficient. So if you have a polynomial, then you know that the possible zeros, the ones that might go into it, have to fall underneath this category. These are rational zeros, so they're a fraction. So when we look down here at 6, we're looking at the numbers that can go into 6. So our possible zeros are going to be the factors of 6 divided by factors of 1. So the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those are your possible zeros. Those would be smart choices of what could go into this polynomial equation. So considering the number 5, thinking that 5 might cross on the x-axis in this location, this polynomial crosses at 5, would not be a very mathematically smart option. Looking down here, we're looking for the possible zeros that could go into this evenly, or where this crosses the x-axis. The possible zeros are the factors of 10 divided by the factors of 2. Now, it's always trickier when it has a leading coefficient. But what we're going to look at are all the factors of 10, because it's divided by 1. So 1 goes into 10, 2 goes into 10, 5 goes into 10, and of course 10 goes into 10. All of those are going to be divided by the 1. Factors of 2, 1 is included with factors of 2. So 1 goes into 10, 10 times, and 5 times, and 2 times, and 1 time. So now we're going to have to divide by 2. So 1 divided by 2. 2 divided by 2 has already been involved. 5 divided by 2. 10 divided by 2 has already been involved. So there are your possible zeros. So what we did is we took all the possible zeros of 10, 1, 2, 5, and 10, and we divided them by 1. Then we took 1, 2, 5, and 10 and divided them by 2. I only listed off the ones that gave us new answers. Some of the others divided by 2 gave us answers we already knew about. Okay, these are considered possible zeros. They're not guaranteed zeros. We don't cross the x-axis 1, 2, 3, 4, 5, 6 different times when we have a cubic. So they're not guaranteed zeros. They're just mathematically smart choices to be considered as zeros. And the way we determine if they are actually zeros is to plug the possible zero in for x using synthetic division. And the question is, do we get a remainder of 0? If we get a remainder of 0, then we know that that is actually a 0 of the function. So let's go ahead and try it. So we're going to come up here and we're going to try to identify what are the possible zeros of this cubic equation. So we're going to look at the possible zeros. So those are the factors of 18 divided by the factors of 1. The leading coefficient is 1. The last number is 18. The last number is 18 divided by the 1. So 1 goes into 18 divided by 1 is 1. 2 goes into 18 divided by 1 is 2. 3 goes into 18. 6 goes into 18. 9 goes into 18. And of course, 18 goes into 18. Those are your possible zeros. Now, which of those possible zeros actually gets a 0? I don't know. There's a whole bunch of choices there. Your choice where you want to start. I would suggest don't bounce around, just start with 1. See if you get a remainder of 0. So I use my coefficients, 1, -4, -15, and 18. I bring down my 1, I multiply. Oh my goodness, look at that. I got 0, so I put a little smiley face inside of it. So we say 0. If this is going to be a 0, then we can say, so x minus 1 is a factor. So now we're given x squared minus 3x minus 18. And we can factor that one apart using x times x, using 6 and 3. Those are two numbers that multiply to be 18, and they add to be 3. We get a negative 3 if we have more negatives and less positives. So x minus 6 equals 0. So x equals 6. X plus 3 equals 0. So x equals negative 3. And don't forget that we said 1 was our other 0. We figured that out, then we figured out the quadratic, then we factored it to figure out the 2 additional zeros. So we're going to come over here to our next one. We have to first look at the possible zeros. Possible zeros are the factors of the constant, the last term, the constant term. So factors of 14 divided by factors of the leading coefficient, which is the 1. When you divide it by 1, it's really easy. Then you don't have to worry about making too much of an extra list. So we get plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. Those are the only numbers that go into 14 evenly. So those are your possible zeros. Those are your mathematically smart choices to try. Thinking that 3 could go into this, or 5 could go into this, or 6 could go into it wouldn't be a very smart choice. But these are your numbers that would be a smart choice to consider. So I'm going to try one. I'm going to try the number 1. I would suggest to always start with 1. So we do 1, negative 8, 5, and 14. Drop down your 1 and multiply, multiply, and multiply. Uh-oh, that's not 0. So 1 was not an answer. 1 was not a 0. So we got to try a different number. You can go ahead and try -1. You can go ahead and try 2. It's your choice. Whatever number you want to try, doesn't matter. We'll just go up the list. Now we'll try 2. Oh, look at that. We get our smiley face. We got our 0. So x minus 2 is a factor. So since that was a 0, then that means I have a quadratic of x squared minus 6x minus 7. And apparently this can be factored apart into x times x And then to multiply to be 7, it's only one particular set of factors. You need more negatives to add to be a negative. So x minus 7 equals 0, x equals 7, x plus 1 equals 0, x equals -1. And don't forget, you also have x equals 2. So those are your 3 different answers for your cubic equation. This graph is going to cross the x-axis at these 3 locations. Okay, let's try it again. We're looking here. All right, why don't you pause the video and see if you can figure out your possible zeros for this polynomial. And then turn it back on and come check it out. So our possible zeros are going to be factors of 35. You don't have to worry about the negative, but it's the factors of 35 divided by factors of the leading coefficient. So that's going to be 1. So our possible zeros are going to be plus or minus 1, plus or minus 5, plus or minus 7, and plus or minus 35. Those are our possible zeros. Those would be the smart places to start trying to figure out our answer. So if we try the number 1, plug in 1, -5, 7, and -35. That was not 0. That didn't help. I guess that rules that one out. So you could try -1 now, or you could try 5. I'll try 5. Hey, look at that. Yeah, my little smiley face. So I have 0. So x minus 5 is a factor. So if that's a factor, then we're going to bring this guy up, x squared plus 0x plus 7. So those would be 2 other answers, but they're imaginary. That means your graph probably doesn't cross again. So x equals 5 is actually the only answer. We could have, or we can support that. We can tell if this is the correct answer by plugging the numbers into the calculator. So if we do our graphing aspect of it and say x cubed minus 4x squared minus 15x plus 18. If you type that into your graphing calculator and hit graph, you're going to probably see that it only crosses in one spot. Did I make a mistake? Let's go back and check. That's not what it, oh, I said 4, but this should have been 5. Oh, I typed in the wrong equation. I'm sorry. X cubed minus 5x squared. That's kind of important that you type it in right. Plus 7x minus 35. Let's try that one. We're expecting it to cross at 5. There it is. It crossed at 5. So if we want to look to see what else is happening, it's got to be making a funny move above the x-axis or below the x-axis. Let's look way down low and take a look at what's happening with our graph. And you'll see that there's some movement happening down here. Okay, we kind of have 2 turning points. Okay, there it is. It looks like it goes straight here, but it probably does not go straight there. It probably curves down a teeny bit. But anyway, there's our curving, so it's only going to cross the x-axis in one spot. And it crossed where we said was 5. So that makes sense. All right, last question. Now take a look at what we're looking at. We're going to start with x to the 4th power. If we do not end up with a quadratic, once we find our 0 and we plug it in and we get 0, but we don't have a quadratic, now we're going to have a cubic. If we don't end up with a quadratic, just look on the graph and try another 0. So since this is a bigger type problem, it's an option. It's not really necessary, but it's an option to use your graphing calculator and do 2x to the 4th power plus 5x to the 3rd power minus 18x squared minus 19x plus 42. So you need to type it all into your calculator. When we graph that out, we can see where it's crossing. We can see the smart spots it is that we should consider looking. All right, you can play with the window even. We see that we don't need to look all the way to the left. We don't need to look all the way to the right. We don't need to look down low super far, and we don't need to look up really far. So we can really zoom in and see where this is crossing at. So this seems to be pretty close to 1, 2, 3, pretty close to -4. Maybe it's -4, but pretty close to it. This one seems to be right on -2. These seem to be in between 1 and 2. Maybe this is like halfway in between 1 and 2, and this one is pretty darn close to 2. Maybe it's exactly 2, but it's pretty close. You can also go to your table. You can look on your table. So I said maybe it crosses at 2, but nope, it doesn't really cross at 2. Oh, but it does cross at negative. but I don't have another 0. So it must be some sort of fraction. So we're pretty sure about the -2, but we're not sure about the other zeros. So what we're going to look for is our possible zeros. Our possible zeros are going to be the factors of our constant term divided by factors of our leading coefficient. So we're going to take the factors of 42 divided by the factors of 2. So the factors of 42 are plus or minus 1. 2 goes into 42. 3 goes into 42. 4 doesn't. 5 definitely doesn't. 6 does. 7 does. 14 does. 21 does. And of course, 42 does. Woo, that's a whole bunch of them. And we got to divide each one of those by 1, which means we're going to get those exact numbers. And we're also going to divide each one of those by 2. Those are your possible zeros of 2, or possible factors. Those are your factors of 2, 1 and 2, go into 2. So I'm also going to consider 1 divided by 2. 2 divided by 2, well, we already have that. 3 divided by 2. 6 divided by 2, we already have that. 7 divided by 2. 14 divided by 2, we already have that. 21 divided by 2. And we already have 42 divided by 2. Wow, that's a lot of zeros. Those are your possible mathematically smart choices to consider as this polynomial is going to cross the x-axis at these possible places. There are smart places to consider, and there are not very smart places to consider, and these would be the smart ones. So we're going to go and just start trying to figure out. We could do it completely blind, or like I showed you, you could plug in your numbers into your graphing calculator. So if we go to y equals, we can type in 2x to the 4th power plus 5x to the 3rd power minus 18x squared minus 19x plus 42. And if you type those in, I think we already did that once, we'll see that it crosses several different times. And we had determined that -2 looked to be our best option. So if those are your possible zeros, -2 was a really good choice to use. So we're going to bring down 2 and 5 and -18, -19, and 42. We're going to bring those down as our coefficients to each of our terms. Multiply, 2, 5, -18, 19. All right, just be sure I did this right. multiply, that would be negative 20, right? And when we multiplied, wouldn't that be 40? Wasn't making sense. Now that gives us 21. Yes, and this gives us negative 42. That gives us a 0, and we're happy with it. You got a 0. So x plus 2 is a factor. So think about this. What are you going to do next? So we're going to turn this into our next equation. This is going to be 1 degree less than it was originally. It was originally a 4th power, so now it's a cubic. This was quartic. This is cubic. Now we look into our calculator to help determine what our possible other zeros are, and we had discussed that earlier. This one doesn't look like one of those fractions, right? We've got those fractions right up here. What are we going to look at? Which one looks like the best choice? Right here at 3.5, or at 1.5. We don't have 3.5, that's 7. 1, 2, 3.5. It doesn't look like we have 3.5, but it does look like we have 1.5. So 1.5 you can use as a decimal, or you can use as a fraction. I like the fraction better. 2, 1, negative 20, 21. Bring it down, multiply. That is 6 divided by 2. That's 12 divided by 2. That's 42 divided by 2. Hey, look at that. Worked out perfect. So we have a 0. So x minus 3/2 is a factor. So now we have this cubic, I'm sorry, a quadratic. This quadratic is not factorable. So we're going to have to use our quadratic, and that's what goes in this line up here. Remember, you can always use the quadratic formula. Quadratic formula can always be used. So our A value, our B value, and our C value. So our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. You can plug in your numbers. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. That is 16 plus, because you have 2 negatives, we're going to get 28 times 4, which is 112, divided by 4. This is going to become plus or minus the square root of 128 divided by 4. That is 64 times 2. So that's 8 root 2 over 4. And since 4 can go into both of those numbers, it has to go into both of those numbers. Those are your other two zeros. So we've got x equals those, x equals 3/2, and we've got x equals -2 as our zeros of this quartic equation.